Welcome to the series on inverse functions with the student Aryan, a grade 8 student in grade 11. We'll discuss a multiple choice test paper with you. Let's enjoy the session with Aryan. Hi Aryan, how are you doing?
I'm doing good, sir. How are you doing?
Very good, very good. So today, what do you want to do, Aryan?
Yeah, the last class we left off at functions. But I'd like to continue functions and then also like start inverse functions, which we started in school.
Sure, sure. We'll do that. So you can share your document
Yeah.
and then we'll begin from there.
Okay. Yeah, this is the first worksheet, and then we can go to the next one afterwards.
Perfect. So you know what functions are, right? Let's have a quick review on functions.
We went over that in the last class.
You know all that, right?
Yeah.
Now, in this case, you have to write domain, range, and relative maximum, relative minimum, increasing and decreasing interval, and the value of the function at some points, f of 1, f of x equals to 2, and figure out this, right? So let's do with the very first one. Can you tell me what is the domain of this function? Question 1.
Your domain is all real numbers.
No. See, it is restricted from -4 to +4, both included.
Oh yeah, I thought like it would just keep going. So then your domain would just be from -4 to 4.
Yeah, -4 to 4. And what is the range?
The range is from 0 to 3.
Correct.
Yeah.
Relative maximum?
Yeah, so I think do they mean like when it's gonna be maximum?
Correct.
So yeah, like the interval.
0, 3 could be a better option rather than just giving maximum value of 3, right? Yeah. Relative minimum, your question is very valid. So relative maximum is maximum value 3 being max.
Yeah.
Right. And relative minimum, there are two. Both are at on the x-axis, so 0 and -2, and 0 and +2, right?
Wait, isn't it 2, 0 and
Oh, sorry. Yeah. Sorry. Yeah. So let me write plus and minus 2, 0, right? So y value being 0. Increasing interval. So let's write.
So it's increasing from like -2 to like 3.
-2 to 0. So we write the x values.
Oh, okay.
The increasing interval, and then from 2 to, so you can write union also from 2 to 4. Is it okay?
4, yeah.
And decreasing will be -4 to -2, and then from 0 to 2, correct?
Yeah.
You can write with comma or union, or also you can write. Is it okay?
Yeah.
The value of the function at 1. Yes.
Yeah. Before that, I have a little question. So, we've always been using like the term union to like describe our sometimes our ranges and domains, but I never really got like a full meaning of what union is. So, what exactly is union and why do we use it?
Okay. Union. That's a very good question. Good you asked me. So let us say we are given two sets of values, right? Let's say this is one set and this is the other set. So I'll give you in context with a couple of things. One is in context to this when we say Venn diagrams. So in Venn diagrams, let us have this is A, set A, this is, or you can say event A, event B. When I say A union B, it means everything in A or B. You understand? This is what it is. You get my point, right?
Yeah.
This means union. Union means also in a way when we say or. Union is same as or. This or that. Now coming back to the number line, if I have this number line here, in this particular case, as you can see, we have two solutions for increasing interval. So let's look into this increasing interval, which is from -2 to 0. So one is, let's say this is 0 for us. This is -4, this is -2, 2 and 4, correct? So we see that from -2 to 0, from -2 to 0, both included is one interval. and then it is again increasing from 2 to 4. So from 2 to 4, it is increasing. This is your increasing interval. Is that okay?
Yeah.
You might write this as x greater than equal to minus 2, less than equal to 0, or from 2 to 4. Is that okay?
Yeah.
So this or which you use can be replaced by union. You understand?
Yeah.
So that is what this or that. And on the other hand, let me show you and also on a number line so that you understand what is and also. And
Yeah.
for example, let's say we have a function whose there are, let's say, some different parameters we are trying to figure out. And let me write down here some values so that it becomes easier for you. So let me write an inequality for the same function. Okay, I'll just make an inequality here. Is it okay?
Yeah, that's fine.
So I'm drawing a line, and the equation of this line which I've drawn is y equals to 1.
1.
Now, I tell you to solve an inequality when is y less than equal to 1. When is y less than equal to 1? You get the idea. We could have one, right? Now, in that case, we know it is between these two intervals and those two intervals, correct?
Yeah.
So this or that will be a union operation. Do you understand?
Okay.
This or that will be a union operation. Okay. When we do some double inequalities, so this is one example. So, well, in this case, the answer will be, let me write down in bracket form. It will be from minus 3 to minus 1. Union, or I can say or, from 1 to 3. Is it okay?
Yeah.
Or operation. Now, let me now tell you and operation. And operation. Or intersection. Or intersection. Let us say we have inequality where one of the inequalities give you an answer that the value is greater than, let's say, minus 2.
Yeah.
And the other inequality gives you a solution that the value is, let's say, let me write 4 here. Let's say it is less than -4. So let's say we have two inequalities, and one is saying that the solution is x is greater than -2. The other one is that x is less than 4, correct? So
Yeah.
what is the actual answer? Whatever is common to this, and that will satisfy the whole equation, correct?
Yeah.
So that will be between the point -2 and 4. You see that?
Yeah.
So that makes the AND operation, or in this case, so you will perform AND operation in this intersection of these two. And the intersection of these two will be from -2 to 4. You get the idea. So
Yeah.
you get to this result after finding the intersection. Okay? So
Okay.
that is what intersection is.
Okay.
Good. So that's clear, right?
Yeah.
Now f of 1. So let's check value of function at 1. At 1, it seems to be at 1, right?
Yeah.
F of x is 2. It means what? When is the function 2, right?
Yeah. At
Tell
1.
me the answer.
Yeah.
X is equal to? It seems it plus or minus half.
Yeah. Oh, yeah. 1/2. Yeah.
And also 4. Do you say plus or minus 4?
Okay.
All the values. So you
yeah.
draw a horizontal line
Yeah.
for f of x equals to 2 and get all the 4 answers. What is
Okay.
f of -3 in this case? -3 seems to be 1, right?
1. Yeah.
Okay. So like this, you can answer all the questions in this particular, these two. Second one you can answer. Now, can you tell me one more property of the function shown in 1? There is a very important property which I see here, and that is it is an even function.
Oh, okay.
Even function really means that it is symmetric about y-axis, right?
Yeah.
Symmetric about y-axis. And mathematically, it means what? It means that f of minus x is equal to f of x. So these are very important things which you can observe from question 1. Is it okay?
Yeah. Yeah.
Correct. So let's move on. Question number 2 you can do, right? Basically similar to question number 1. Let's see the next question, please.
Yeah.
Okay, so let me check with you one answer. Where for the given function, what is the value of x when f of x equals to minus 6? How will you do this?
So you just draw a horizontal line on y is equal to minus 6.
Correct.
I'll zoom in that way.
Yeah, now it's more clear.
Yeah. So then your minus 6 would just be when x is equal to minus 9 and minus 4.
Minus 9 and minus 4 is the right answer. Perfect. So yeah, you can zoom back. Perfect. So we get minus x equals to minus 9 and minus 4. Correct.
Yeah.
Yeah. Next question. Yeah. Continue. Now, yes, interesting question. Question number 4. Can you give me domain of question number 4? So we have different pieces here, right?
Yeah.
Now, first thing, is it a function?
No, it's not.
It is a function because at this point it has a hole there, right?
Yeah. It has.
So yes, it is a function.
Okay.
It passes vertical line test. Now, what is the domain of this function?
So I think it's negative 10 to 0, union 0 to 3, union 3 to 10.
Because these are points included, you can straight away write negative 10 to plus 10. You get my idea?
Oh, okay. Yeah, I didn't see
because there is no discontinuity.
Yeah.
I mean, not in the domain, not in the domain, nor even in the range. Okay. So, and about the range, can you tell me what is the range of this function?
Yeah. Negative 4 to 7.
Correct. So negative 4 to 7. And what is included? What is not included? So in the first one, let me just erase and rewrite. So when you say domain, you have to write close brackets. Negative 10 because we have filled in circle. Do you see that?
Yeah.
So both are included. As far as the domain range is concerned, negative 4 is included. However, negative 5, a positive 5 is not included. Do you see that?
Yeah.
So that will not be a square bracket. Perfect?
Yeah.
So now in this case,
wait, I think he means
the relative maximum.
Isn't the range negative 4 to 7 not inclusive?
Okay, is it 7? Okay, 7.
Yeah,
but not included. Yeah, that's okay. Now in this case, what will you say the value of relative maximum is?
One to like it's from the interval of like from 1 comma 0 to.
So we will say not defined.
Oh.
Because there's a hole there. Do you understand?
Oh, okay.
But the relative minimum is defined.
Okay.
So which in this case is minus 3, minus 4, I mean. Which is also the absolute minimum. You get the idea?
Okay.
Increasing interval.
Yeah. Yeah, that's from 0 to 3. Yeah.
Correct. And the decreasing interval?
Isn't there 2 for decreasing? So negative 10 to 0.
Correct.
And then union 3 to 10.
Correct. Value at minus 8?
Yeah. I'll zoom in. Yeah.
Seems to be 1. No
Yeah,
need.
1.
Is it
No,
1 or 2? Wait, wait, wait.
it's
It,
like I think it's
1,
1.
1,
It's
1,
minus
1,
1. Minus
1,
1.
1.
Yeah.
Minus 1.
Minus 1. Yeah.
F of x equals to minus 3. Let's do it when it is closed. So minus 3 is here, right?
Yeah, it's like minus 3.
Minus 2, right?
Looks like it's minus 3.
Wait, let me erase.
Yeah.
0. So when I say f of x is minus 3, we are looking at this point and okay, it's
Yeah,
in
that's like,
between.
it's like in between. Yeah, it's not like a perfect.
Okay, you could say minus 2.5.
Yeah.
Okay,
And then
f of 5. F
5.
of 5 you can read from here.
It's
This
like
value.
it's 3. F of 5 is equal to 3.
2, 2.
Wait, f of 5, right?
Yeah,
So
5.
that means x is equal to 5. So
Oh, sorry, you're right. I'm so wrong. You're right. F of 5. Yeah. 3. Correct. So let's clear this. Move on. Yes, next question, please.
yeah, these next questions are just easy questions. So we
Yeah,
can go to
move
the
on.
next one.
Then don't. Yeah, you can grab these. No problem.
Yeah, those are just easier. So
Correct. We'll
yeah,
skip this.
so yeah, this is the next one. Can you see it? It's like
Yeah, I can. Yes.
yeah, they're about
Okay.
inverse functions.
You have
So
to find the inverse function. Okay. So finding inverse function, there are many strategies which you could use, right?
yeah,
The common strategy is step number 1, we swap x and y.
yeah,
And then we solve for y.
yeah,
One thing. Second thing, when you do inverse function, it is very important to write down domain and range, right?
yeah,
And domain and range also swap, correct?
yeah.
So you have to do both the things. Now, in this particular first one is, what is the inverse of y equals to 4x squared plus 2? So using your method of swapping and then solving, let us do it and then figure it out. So we have y equals to 4x squared plus 2. I'll swap. So I'll write x equals to 4y squared plus 2. Then we have x minus 2 equals to 4y squared. X minus 2 divided by 4 equals to y squared. And then when you do square root, it becomes plus and minus. So don't forget to write plus and minus. Is that okay?
Okay. Yeah.
Equals to 4 y. So
Y.
we get the answer x minus 2 with plus and minus divided by 4, which is the right answer for you. Correct. Now I will also like to show you one more strategy to find the inverse without algebraic calculation. This is very important.
Okay.
So I call, in fact, it is a standard method. So inverse by reverse operation. Operation using words. Okay. So if you see the forward operation, how do you calculate y from x? First you square the number, right?
Yeah.
And then you times it with 4, correct?
Yeah.
And then you add 2, correct?
Yeah.
Now what is the reverse operation? If you do from here, what will you do first? What is the reverse of? You start with
Minus
a number,
2 divided by 4.
x
And it's
minus
squared.
2, and then you divide by 4, correct? And then
Yeah.
you square root. Do you see that? And whenever
Yeah.
you square root, write plus and minus. Do you see we got the same answer?
Yeah.
Without calculation, we have done inverse of a quadratic function written in vertex form. So this is a very neat way of doing it. And you could actually check your results also sometimes. Perfect?
Yeah.
And is this inverse a function?
No.
Not a function, correct? Because it has two values, plus and minus. So all these things come together. You have your right answer. Let's move on. Get the next one.
Okay.
Now tell me, what is the answer? You do your calculations. I'll just do slowly calculations, give you time to complete the work, right? So we'll first swap. So first step is swap. And we have x equals 2.
Yeah, I think I got it.
Yeah.
Yeah.
Then we'll cross multiply.
Yeah.
Very good. Very good. So y equals to 1 over x plus 4 is perfect. That is correct. Next, please.
Yeah.
3x cube minus 4. So you will add 4 to this and then divide by 3 and then you do cube root, correct?
Yeah.
So I'm doing by words. Add 4, divide by 3, and then you do cube root. So you get B as the correct answer. This is right. Perfect. Next question, please.
Yeah.
Good job. G of x is given to you. You need to find inverse of this function, right? So let's swap and then write down y minus 5 plus 2, x plus 2, and then you square this, and then you add 5, and there is a mistake in this question. Okay, so Aryan, you have the right answer as per the choices go, right?
Yeah.
Now, strictly speaking, there is a mistake. Can you identify the mistake? In this inverse is a function, correct?
Yeah.
But if you see the inverse, this function, what is the domain of square root function? X has to be greater than or equal to 5, right?
Yeah.
And what is the range of this function?
Y
is greater than or equal to minus 2. Is it okay?
Yeah.
So therefore, when you find the inverse of this function, you will write here that the domain of this function should be x greater than or equal to minus 2. You understand?
Yeah.
Because it is only the right side of the parabola which we are interested in, correct?
Yeah. Yeah.
So if you sketch it, let me just do it here. And this is your square root function, which is moved 2 units up, 5 units right? Let us say this is your square root function. Is it okay?
Yeah.
Now, you're saying the vertex is at 5, 2 and 5, right? So, okay, so this was what? This was square root function at 5, and this is 2, right? Now we are saying the vertex is at 2 and 5, so somewhere here, right? So, but it is going like this. Do you see that?
Yeah.
We are not, this is not the part of inverse, but this equation doesn't show that. It shows the full parabola, correct?
Yeah.
Therefore, the parabola has to be restricted, and this restriction should be placed when you write inverse of this function in the test, okay?
Okay.
Okay, so let's clear this and move on. Okay, can you please read the question and answer?
Yeah. So if negative 3 comma 1 is in the function f of x, then which of the following points will be in the function f of negative 1 f x?
Tell me.
I think, is it 8 or?
Yes.
Okay.
They will just swap. So the points swap, and you write question number 6, please.
Yeah, this is just a similar, so I can see.
Yeah.
Yeah.
Correct.
Now, which pair of functions are inverses of each other?
Correct. So see, this time they are giving you the domain. Do you understand?
Yeah.
They're only looking into one part of the quadratic equation. That is correct. So this time it is correct. Okay. So on this parabola, we are seeing that the domain is less than x is less than this, and here, and what is y? Y is greater than 2, right?
Yeah.
So the domain will swap, and this we get x greater than 2 as your domain, right?
Yeah.
So x greater than 2, and y should be, so you have to look into the domain now. When you say x is less than 1, then this parabola, you're talking about left side of the parabola. You get the idea?
Yeah.
And square root also is, they are talking about downside. So this is correct.
Yeah.
Which pair of functions are inverse of each other?
I think it's D.
Okay, so calculate.
Yeah. So I just
both are positive. So when you do x minus 6 divided by 2, square root, and because you're taking positive, you're saying the positive part, so that is correct.
Yeah.
Okay. Now,
Okay.
left side also. Now let's look into this. X minus 2 divided by 3, but this negative doesn't work out, correct? So this negative is wrong here, right?
Yeah.
And therefore, D is correct.
Okay.
Next.
Yeah, similar type of question.
Similar type of. Can you answer this?
Yeah.
Tell me. So we will do X. First we'll add 5, correct? And then we square, and then we subtract 1, correct? So with reading it properly, you can answer the question, right?
Yeah. I think it's A.
Correct. A is correct. Next, please.
Yeah. Yeah. Which graph is the inverse of the graph shown?
Correct. So it has to right open, right?
Yeah. So it's B.
Okay. You can check the vertex also. It swaps X and Y just to be very sure about it. See, what is the vertex? 0, 2, right? Minus 2. So minus 2, 0 will be the vertex. So whichever has minus 2 vertex, 0, that is correct.
B. Yeah.
You are right.
Yeah. The graph of f of x is shown here. Identify the graph of the intersection. So
yeah, you can just.
Yeah, I think it might be C.
Okay. So let's look into the graph once again, please.
Okay.
Just see the vertex. So
Yeah,
in the graph,
0,
vertex is 0, 2, right? So now you're looking for 2, 0 positive, right? 2, 0 positive.
Yeah. And that's why I got C.
2, 0 is correct. You are right. 2, 0 positive.
Okay.
So very simple strategy. Go with the vertex. Correct.
Yeah.
11.
Yeah. Which of the following graph is the inverse of y is equal to negative x minus 2 squared minus 3?
Correct. So you will, this parabola actually is opening down. This parabola is opening down. And this point here is at 2 minus 3, right?
Yeah. So they just swap, and it's negative 3 comma 2.
Negative 3 comma 2 is the vertex now.
Yeah.
And it will open left.
Yeah, I think it's A.
No.
Because none of them open left, really.
They're D.
Is it? Oh, okay. Yeah. Oh, yeah. Yeah. I didn't
Be careful.
I didn't see the negative. So
see, so very simple strategy, correct? Left or right, and where's the vertex? You got it.
Yeah. Okay.
12. Which of the graphs best represents the inverse of the function half x? Okay. So half x, basically half x is this graph, correct?
Yeah.
Inverse kind of a logarithmic function because it's an exponential function. Have you done logarithmic functions?
No, we actually didn't deal with logarithmic.
But what you can do now, if you're not done, draw a line, right? Y equals to x, and reflect on the line. So you get this is your half x, and C is your answer.
Okay.
So have a good look at it. Half of x is this function is a decay function, right? Exponential decay, correct?
Yeah.
So we have a function which is decreasing, and if you draw a line diagonal and reflect it, you get the inverse of this particular function. But you should know at least which function is half to the power of x, right?
Yeah.
Correct.
Yeah. So the data below is for a certain function h of x. Through which of the following points is the inverse function h of negative 1x have to pass?
Correct. So you can look for points, and y value becomes the x value, correct? Yeah. So I think the value which is given here is this, correct?
Yeah.
Continue.
Yeah. So the values in the table below satisfy the function g of x. Same problem basically. Same problem. So the answer is
so match with your gx values. So if you find something common as you have identified, 11, 2 is the correct answer. Correct.
Yeah. What restriction can be made to the domain for f of x is equal to 2 plus absolute value of x. So that f of negative 1x would be the function.
Yes, tell me.
I think it's x is less than or greater than negative 2.
No.
Oh,
2 plus absolute value of x means that the function has been translated up, right?
oh yeah, that's right. Yeah. All right,
And
okay.
you want to avoid horizontal line test. So either you go left side of this or you go right side of this.
Okay.
I mean left or right. So you are going one side of 0, okay?
Yeah, okay.
Correct. Move on.
Which function is the inverse of y is equal to negative 1/3 x squared plus 2?
Do the reverse operation. We have y minus 2, right? So because when you do this, you have to first square the number, then you have to divide by minus 3. So in this case, you will multiply by minus 3. Is it okay?
Yeah.
And then you will square root with plus and minus. Now, because it is greater than equal to 0, you will do plus. Is it okay?
Yeah.
So that is what it is. So 3 times, when you multiply 3y minus 6 square root plus. Do you have 3x minus 6?
No, but don't we have to keep it in terms of y is equals to?
Yeah. Then you will write y
Yeah.
equals square root 3x minus 6.
Yeah.
So swap, yeah.
3x minus 6. That's not a choice.
Minus,
Yeah,
when you do this minus 2, okay. When you multiply by, you have to multiply by
plus
minus
6,
3. Yeah,
yeah.
sign will change. I'm sorry.
Yeah,
It is minus 3 also. Yeah.
Yeah.
I'm sorry. Yeah, 6 minus 3. There was minus 3 also. Yes.
Yeah.
Correct.
Which function is the inverse of y is equal to 1/4 x squared minus 1?
Correct. Tell me. So add 1 to it, multiply by 4, and then square root. And take negative sign because it is less than. So they have written is 4x plus 4. And 4 is common, correct? With minus, so minus 2, x plus 1. Correct. That is the right answer.
So what is the domain of the inverse function? What's the domain of the inverse of the function y is equal to negative 2x minus 1 squared plus 3?
So you have to look for the range of this function, right?
Yeah.
So range is less than
3.
Less than equal to. Correct.
Yeah. F of x is equal to the square root of 3x minus 12. Find the range for f of negative 1x.
That means find domain of this, right?
Yeah. So I
So
think it's
3x
4
minus 12 should be greater than equal to 0. 3x is greater than equal to 12. X is greater than equal to 12 by 3, which is 4, right?
So 4 to
4 to infinity.
Yeah. Yeah, similar problem here again, where it's negative 2 to infinity, I believe.
Correct. So you just find the 0, it is right side of that, which is 2, correct? Minus 2 to infinity is correct.
We'll have another worksheet. It's like another online.
We can do many inverse related questions from my videos. Okay. Let me just share.
We can do that. That's fine.
We can do that, right? So we'll do inverse. So let me give you whiteboard some questions. So I'll just give you a few functions to do inverse. Okay. So let's say I have the function y equals to. We did not see this kind of a function, rational equation, right?
Yeah.
X minus 5. Can you find inverse of this? So first tell me domain or range of this function.
Yeah. The domain of this function is
because there's a vertical asymptote at x equals to 5, so that will not be included for sure.
Yeah.
And as far as the range is concerned, you have to figure out what is the horizontal asymptote, right? So in this case, you have to find horizontal asymptote. Can you figure this out?
Yeah.
Tell me.
X is equal to 5? Or
no. X
No.
equals to 1.
Yeah, 1. Yeah.
1.
My bad.
So that becomes a value which is y is not going to approach. So that becomes the range. Is that clear to you?
Yeah.
Now, let us figure out how do we find inverse of this function. So you inverse of function, right?
Yeah.
So you'll swap and then simplify, right?
Yeah. So I think it is I think it's 1 plus 7 over y is equal to, or, no, I'm thinking in terms of y.
So did you get your answer?
No, not really.
Okay. So solve
But
this out.
I'm
Swap
still,
x and y, solve for y.
yeah, I got it. I got my answer.
What is your answer?
Yeah, I got what you got as well. I got y
Okay.
is equal to
Now
5.
you have to write domain and range for this function.
Yeah.
So you know it will swap. So you can write in your notation, which is x belongs to real numbers, where x is not equal to 1. Do you see that? And you can
Yeah.
check it is in the denominator asymptote, right? Y is not equal to 5. Perfect. Whenever you do inverse, you should write domain range of both function and its inverse. This is kind of a must. Is it okay?
Yeah.
Perfect. Now, this is one question. Let me give you another very beautiful question based on rational function. And we call this as a self-inverse functions. Give me 5 examples.
Yeah.
Can you give me 5 examples of self-inverse? Means inverse is same as the function itself.
Oh.
Yes. So try.
So, like, what if like y is equal to x, y is
Yes.
equal to negative x,
Yes.
negative y is equal to x.
So that is same thing.
Yeah, and then negative, and then y is equal to 1 over x. I think.
Correct. Y goes to 1 over x. Correct. One more.
Y is negative y is equal to negative x. Does that work?
Okay. Let's understand the concept.
Okay.
So self-inverse means that the function will uh, be reflected on itself. When you reflect it on the line y equals to x, right? So if I have this line y equals to x, then it gets reflected on itself. That's the whole idea, right? So you will notice that if I have any function which is perpendicular to this line, will reflect to this line, correct?
Yeah.
So that means I could write y equals to slope of minus x, correct? Plus any number constant k. K could be 1, 2, 3, 4, any y-intercept. If you find inverse of this function, it will be the same function. You get the idea?
Yeah.
So that's the whole thing. You can check this. So let's check. So if I have y equals to minus x plus any constant k, if you swap, then what do we get? We get x equals to minus y plus k,
Okay.
and then we get y equals to minus x plus k. So you see both are same, correct?
Yeah.
So that is how you get inverse of this particular function.
Yeah.
So when it is a straight line, it is very simple. Because the concept is it is perpendicular to y equals to x, or it coincides with the same line. Is it okay? So it is reflecting on itself. Now here is a question which is seen in the test many times, and that is, okay, so what is f of f inverse of x?
Yeah.
Inverse function of, have you done composite functions?
No, we start that next week.
Oh, next, okay, so we'll skip this one. Fine. So let me now give you a rational function, right? So we have a function r of x, which is equal to, let's say, x plus 2 over x plus k. My question to you is, for what value of k is the function self-inverse? So this is very interesting. So you can actually get an idea that a particular value of k will always give you a self-inverse function when it is a rational function also. Like in line, you know, the slope or the gradient should be -1, correct? To be a self-inverse. How about a rational function? So swap and do and check. So we'll do x equals to y plus 2 over y plus k. So we get x times y plus k equals to y plus 2. xy minus y equals to kx, minus kx plus 2. So y common. We get x minus 1 equals to minus kx plus 2. And then y equals to minus kx plus 2 over x minus 1.
Yeah.
Is that correct? Okay. So what value of k will make these two functions equal? That is what you have to look into, correct?
Yeah. -1, maybe?
-1. Perfect. Do you see such a beautiful question? It comes in multiple choice and it is a very difficult question. Now we have done a general solution of a rational function. So whenever, now if I write the equation, any equation, let's say y equals to, let us say x plus 7 over x minus 1. You know it is self-inverse. You see that? It is a self-inverse function. You'll get the same value. Okay. So that's very interesting and a very useful example from a test point of view. Simple examples you could have given. If I have y equals to, let us say, 2, 3, 3, 4, 4, 5, let's say 7, 7. Now you can find the inverse of this function.
Yeah.
Just swap the points, right? Okay. So from here, it is very clear. If I ask you to give me a self-inverse function, you'll say, well, self-inverse function could be this. All same points, right?
Yeah.
Anything you could write. So that could be a very simple example for a self-inverse function, right?
Yeah.
So what I'm trying to say here is that we should not restrict ourselves just to equations. We could actually give functions are represented in so many forms, right? So we could write self-inverse function inverse. We can show it on a graph. We could write this as a coordinate point set, which I have given you, or an equation, correct? So we could do this. Okay. So at this stage, I will actually now tell you to look into some of my videos. I'll stop sharing this. Okay. 1. Can you summarize what did you learn in today's lesson on functions and self-inverse? And inverse of functions.
So basically, I've learned that like the domains and ranges like switch. That's one thing.
Yes.
And how to like go from your normal function to an inverse function by just swapping your x and y values and like swapping your x and y, and also like how the graphs kind of look like. Like we kind of briefly went over that you're while doing that one worksheet. And yeah, basically that's mostly it. And we also went over the self-inverse functions,
Yeah.
how the points like change.
Sweep,
And
swap,
yeah,
yes. And one thing is, inverse of a function may not be a function. So
yeah,
sometimes we may have to restrict our function so that the inverse is also a function, correct? So now you can actually go to YouTube channel, just search Anil Kumar,
yeah,
inverse functions, and we'll look into some videos, okay?
yeah. Should I just search up inverse functions?
Yeah, inverse functions, yeah. Maybe test, inverse function test. Anil Kumar, inverse function test.
Yeah,
And then, yeah,
let me share.
then you share, yeah, you can share. And you
Can you
can
see
take
what's
up a
here?
test paper from my YouTube channel and then work on it. So see, when you see this, inverse function exam with, so first one, run first one.
Okay.
Very beautiful question. Have a look at it.
Okay.
So you can try these for 4 questions, right? The very first is inverse of the function, this is given to you. Second is inverse of the function f of x, x squared does not exist. That you know now, right? Inverse of the given function where x is greater than equal to -1. And this is what we are talking about, inverse of inverse function, right?
Yeah.
So I will actually elaborate on question number 4. You can later watch it. It is an important concept, right?
Yeah.
Inverse is what? It comes from the basic concept itself. Let's say we have a function here, correct? So if there's an input x, then we are getting an output f of x, correct?
Yeah.
Inverse basically is a reverse operation. So if you plug in f of x, then you should get x, correct?
Yeah.
So this operation of function and its inverse will always result into x input. So you get back the input which gave you the function. So that's the whole idea. Is that clear to you?
Yeah.
So that's again very important. Now you can look into some other video. Yeah, just search again. I mean, click search on this and then you'll watch some other video.
Yes.
So that was a true or false statement. Now move on. Continue. Okay, continue. We'll look into some questions. That's a long video. Okay, continue. Okay, we have done this kind of function where we had some dots like this and discontinuities. We have also done the rational function, correct?
Yeah.
Okay. Combined with inverse mock test. Okay. So when you see this combined with inverse mock test with ME, these are actually very difficult questions at times. So run this video. Where we are taking papers, test papers from EdXL, which is in UK.
Okay.
So test questions from those test papers are taken. So you can go in the center of the video somewhere in between. So do you see we are discussing at length this chapter on inverse functions to figure out how do we, find, and there are many examples which involve composite functions. Inverse functions become very difficult or tricky when we are involving more than one function. Is it okay?
Yeah.
So Aryan, I'd like you to go through this video itself. It will help you.
Okay.
And you will be ahead of your class because you said soon you're going to start with composite functions, correct?
Yeah, that's what we're doing next week.
Next week. So you can do this couple of minutes and you'll get both ideas how inverse functions will be clubbed into composite functions because this becomes slightly tricky later on. Is it okay?
Yeah.
So that's good. So I think we can end our class now, but you go through this video and you can check some more videos on my playlist.
Okay. Yeah, one more thing, like
Yeah.
before we end.
Yeah, sure.
So if it's like a like can we like just quickly like maybe like if we have enough time, can we just
Yeah,
like quickly
we
go
have. Don't worry. Yeah.
like like can we just quickly go over like the basics for like a composite function and like what it basically is asking for? Like
Okay. So let me just show you that on a whiteboard. No problem.
yeah, I just wanted to like quickly
Yeah, yeah.
understand.
Yeah. So when we say composite function, so let's say we have one function. I'll keep it very simple. F of x is, let's say, 2x plus 1, right?
Yeah,
And let's say g of x is equal to x squared. Let us say, right? So when we say f of g, we write sometimes like this, of x, it means, which is also written as this, f of g of x, right? You get the idea.
yeah.
F of g of x. Now, when you write like this, it means that the argument, which is independent variable, which is x, now has been replaced by g of x. You see that?
Yeah.
So basically, this will be equal to what? The function 2x plus 1, the x value will now be replaced by this value of g of x. So I'll write this as x squared and plus 1, and that becomes my function. Is that clear to you?
Yeah.
Let me take another example. This was too simple. So again, I'll take f of x as a linear function. Let's say 3x, well, let's make it this, minus 1. And g of x, let's take it as 2x plus 1, correct? So in this case, if I have to find what is f of g of x, we start from inside out. We start from inside out.
Yeah.
Means start from here. So you say f of, what is g of x? This value, right? So we write 2x plus 1, correct? Now what is
Yeah.
f of 2x plus 1? Replace this with 2x plus 1. So 3 times 2x plus 1 whole square minus 1, correct? So you get
Oh,
function
okay.
of function.
Yeah.
So that is the basic concept, right?
Yeah.
More to
Okay.
it is now relating domain of this function will be restricted on the domain of g of x, correct?
Yeah.
So, but you got the concept, right?
Yeah. I understand.
So that is how you're going to do it. So I hope
Okay.
that helps. So let me clear this, and once you get to know more about it, we can discuss further.
Okay.
Okay, great. So we can end the class now. See
Okay.
you soon.
Okay. Thank
Okay
you.
then. Bye.
Have a good day.
Bye.
Bye.
All the best. Thank you.